What's up, everybody, and welcome to Surfing 101 Understanding Tides. Now today we're going to walk you through what the tides are, how they are formed. We're also going to talk about reading tidal charts, how we can make sense of all the numbers, the squiggly lines, all the information that you're given while looking at a tide chart and what it means for your local break. And lastly, the information we really want to know, which is the tides and waves, how different tidal conditions can affect the wave conditions at your local break. So guys, we're going to get started right away talking about what are tides. Let's go. All right guys, so the first important thing about tides is to understand how they're formed and where they come from. So I'm going to do my best to explain it for you guys now. So how are tides formed? Well, tides are formed by the gravitational pull of the moon as well as the sun. Now, particularly, it's only the moon. The sun does have an effect on it, but because the sun is so far away, it's much smaller. So what happens is the moon is going to circle the Earth. Now, as the Earth spins, the gravity of the Earth keeps the water in one place, and then the centrifugal force, which is the force of the Earth spinning, wants it to go out, so it keeps the water from changing. It basically stays at one level, sea level. But the moon and Earth actually circle around each other, so there's a central point here. The moon circles around that point, the Earth also circles around that point, and it causes basically a bulge of water to come out towards the moon. So when the moon's over here, there's going to be a bulge of water, a higher tide on this part of the Earth where the moon is pulling around. Now, because they pull around a central point, there's also a bulge of water on the opposite side. So that means there's two highs at any given time on the planet. There's going to be a high tide on the same side as the moon, and there's also going to be another bulge of water bulging away from the moon on the opposite side because of the fact that they rotate around a central point. So the gravitational pull of the moon and the sun is what causes tides. Now in between, so we have over here on the side of the moon, on the far side for the moon, we have a high tide. So in between here and on the opposite side of my 2D Earth here, there's going to be low tides because all the water pulling here and here is going to draw water away from the other areas. So at any given time, like I said, there's going to be two highs on the planet and two lows. Now, how does the moon and sun work together? Well, that gets into spring and neap tides, and it's something you're probably going to hear, spring and neap tides. Now that has nothing to do with the seasons. The spring tides are typically higher tidal swings, and the neap tides are smaller tidal swings. They call them spring because they spring out. The tides are bigger. Now what happens is when the moon and sun are in line with each other, so the sun's pulling as well as the moon, it's going to cause a higher high tide here and a higher high tide here and lower one in between. So that's when they're lined up, such as when there's a new moon or a full moon. Now what we call neap tides typically means smaller tidal swings. So that means the sun is going to be over here and the moon and sun are going to be at 90 degrees with the Earth. So the moon's over here, the sun's over here, and they actually kind of work against each other to make smaller tidal swings, which is why sometimes in the month you're going to have really, really big tidal swings and sometimes you're going to have really, really low ones. So that explains the spring and neap tides. Now, there's some other vocabulary that's kind of important to understand, and it's diurnal and semi-diurnal. So a diurnal tide is when you have two tides a day because the moon circles the Earth. In certain parts of the ocean, you're going to have one high and one low. Now, a semi-diurnal tide is what most places have. Most of the east coast of the Atlantic, most of the Pacific, and that's where you're going to have two equal highs and two almost equal lows. So you'll have a total of 4 tide changes happening every 6 hours, 6, 12, 18, 24, 4 in a day. So that is where tides come from. So now let's show you some tidal charts and how we can interpret them and translate them into the ocean where we're surfing at. All right, so now we're going to talk about how to read and interpret tidal charts. Okay, so I'm going to show you the two main types you're going to see on either the NOAA websites or any your favorite surf forecasting website. So the first is just kind of a text chart. So most of those are going to look just like this, and this is just a sample of one that we have here in Costa Rica, and it shows H1, L1, H2, L2. So there's 2 highs and 2 lows throughout the day at roughly 6-hour intervals. Now, one thing to remember is that the moon doesn't actually circle the Earth in 24 hours. It takes about 24 hours and 50 minutes, which means that if high tide is at 12 p.m. today, the next day's high tide will be at 12:50, the next day's at 1:40, approximately 40 to 50 minutes later each day, depending on what part of the Earth you're in. And that'll show actually in the charts. So here we have high 1, low 1, high 2, low 2. So this shows you the first high of the day is at 6:46 a.m. And the next number is going to be the difference in feet from sea level. So In Costa Rica, we have large tidal swings. The first high tide on this day was a 9.05 foot high tide. That's a very large tidal swing. Okay, so the first low tide, I'm sorry, ends up being about 6 hours and 3 minutes later. Not exactly 6 hours. And you notice the tide dropped from a plus 9.05. So that's one part of terminology you'll hear a lot is a plus tide or a minus tide. It drops to a minus tide. So it actually drops a total of like 9.3 feet. That's a huge tidal swing. So now it drops to negative 0.26 feet. So that means it's about 0.26 feet below sea level. Now the next high is at 7:13. So now you notice from this morning's high tide to the evening high tide, it's been about 12 hours, 12 and a half hours, about 12 hours and 20 minutes. This next high tide is even just a little bit higher, maybe because of the moon, where the moon's at that point, and it's 9.39 feet. And the next low tide is, you can see, about 6.5 hours from the first low tide at 1:25 in the morning, and it's almost a negative low tide at 0.19 feet. So one thing to realize that when you look at these numbers is that here in Costa Rica we have large tidal swings sometimes. So in this case, this is about as large as they get. So that means at 6:47 p.m. or a.m., the tide's going to already be dropping out. Okay, so that means that if there's a large difference in the number here, the tide's going to change much faster. The tidal conditions aren't going to stay similar. Whereas if this number here was 2 feet and this number was 0 feet, a 2-foot tidal difference over a 6-hour period is obviously much less significant than a 9-foot tide difference over a 6-hour period. So the other kind of graph you're going to see, or a tide chart, is in graph form. So I have two shown out for you, and they're pretty much always going to be the same. On the side here is going to be height, either in feet or meters, and this is going to be time, and typically it's going to be hours of the day. So like 12 o'clock, 6 o'clock, 2 o'clock, whatever. This is going to be the time. So it kind of looks like a sine graph, if you remember from algebra, calculus, whatever that's from. So here on the side we have the height in feet. So early in the morning, 6:45, you can tell that up here, that's the peak high tide, and typically it'll have the number in feet up there, and then the time down here, and you can follow the graph and see what part of the day. And as you notice, the graph, the tides are always changing. So the tide typically doesn't stay high for very long. Maybe in this section here, you would consider peak high tide, you consider this area peak low tide, but it's always important to remember that the tides are always changing. They don't stay set. As soon as it hits dead low, it's already on its way back up within 30 minutes or so. But within maybe 30 minutes to an hour, depending on the tidal swing, is how long the tide will stay that way. So this would be an example of a semi-diurnal, where you have two highs and two lows that are pretty similar. And that's the most common, unless you're surfing in a bay or a gulf, where you'll have some refraction due to the way the water moves in and out, and you'll have a tide that looks like this, more diurnal tide. So you see we have a peak high here. So this is the highest high tide of the day. Then it drops down to what I have a negative low tide. So that's a huge tidal swing. And that's going to be still in a 6-hour time frame. Now over the next 12 hours, the tide's going to come up just a little bit and then go back down a little bit before it jumps to the next peak high, peak low the next day. So it's important to realize for your local spot how this is going to affect. So this is how we're going to read tide charts. Now that you understand that, we're going to talk about tides and how they can affect the waves at different kinds of breaks. All right, and finally, the part you've all been waiting for is the tides and how they're going to affect the waves and affect your surfing. So one thing to note is that tides affect all breaks differently, whether it be sand, reef, point. So it's good to do a little research on your particular break. There's lots of information out on the internet. There's a website called Wanna Surf, Surfline. You can just pop your local surf break into Google, and more than likely you can find some great information about your local break. Certain breaks are going to be really good at only high tide, and then at low tide maybe it's too shallow or there's exposed rocks or reef, whereas some places may not ever break at high tide, but they'll only break at low tide. Some are a combination of both. But I'm going to give you some generalizations you can make about the tides and how they can affect the waves. So we'll start with high tide. So high tide, we know that the water level comes up, so that means there's going to be more water over the reef, over the sand, over the rocks. Well, that means it's going to be deeper, and typically the waves are a little slower breaking and they're a little less steep because the waves aren't coming up and slamming onto a shallow sandbar or a shallow reef. Now, one piece of terminology you'll hear a lot is incoming tide or tide push, or when the tide fills in. Typically when the tide goes from low to high, you have an extra surge of water coming up towards the beach, and that can actually act to help increase the frequency and the size of waves. So now you know if someone says, yeah, it's going to get better with the tide push this afternoon. That means that as the tide goes from low to high, as that water fills in, it's going to actually help increase the waves. And that's pretty common. Too high a tide can actually cause the waves to disappear, especially with a smaller swell or a shorter period swell. It makes it deep, and the waves aren't strong enough, and the energy of the wave doesn't extend deep enough into the water for it to feel the bottom and lift up and break. So the wave will actually run all the way until it hits right a few feet from the beach before it crashes. Okay, and really important is higher tides can be really a lot better for longer period swells. Basically, a longer period swell has more energy. As the energy moves through the water, it moves in circles, and it doesn't have a lot of friction, just the friction of the water. It doesn't start slowing down and losing energy until it starts interacting with the bottom. So if there's more water before the waves come in to break, the raw energy of the swell can actually push through that deeper water unaffected by the bottom until it gets shallow enough to break and then turn into a larger breaking wave. So typically longer period swells like a little more water, water over the reef or over the sandbar. Now moving over to low tide. Low tide, we know, is when the water sucks out. There's going to be less water. It's going to be more shallow over the sand, over the reef, over the rocks. Typically, it makes faster breaking waves. The waves can be what's called drained out. It's another piece of terminology. When the tide gets too low, or in the last few hours when the tide is pulling out, it can actually negatively affect the waves, make the waves disappear, or become less frequent because of all the water pulling out. It doesn't allow as much swell to get in. It could be better for shorter period swells. And so just like a longer period swell, the raw energy of the swell is able to make its way in unaffected by the bottom. When there's less water, the energy of the wave here is actually feeling the bottom. Because a term you'll hear is the wave's feeling the bottom. So the wave energy is feeling the bottom, and it's causing friction. It's causing the wave to slow down and lose energy, which is why a lower tide can affect it. Now, this typically is for sand bottom breaks at a reef. For example, the waves are always coming out of dry, deep water and hitting a shallow ledge, for example. So at a higher tide, that means that there's just a little more water over the reef, and a lower tide, a little less water, so it can change the conditions, make it more or less dangerous, more or less fast, cause the waves to go from slopey to barreling in a matter of a few hours. So, guys, this is a basic breakdown of the tides and how they can affect the surf and your local area. Always, like I said, great idea to do some research of your own. So I'm going to be coming out with lots more videos, lots more surfing one-on-one videos on wind, waves, anything you can think of. If you have any questions, comments, put them in the comments below. We love thumbs up. And guys, be sure to subscribe for all the great surfing tips, surfing 101, everything that Surf Coast and Shaka has to offer. So we will see you guys in the next video.